This is the second of two videos discussing the cabin heating system of a Boxer Ducato Jumper style van. This part focuses on the electrical related issues, so where it is the fan that is not working correctly. If your problem is it only blows cold air, check out part 1. I will begin by diving into the wiring diagram to explain how the electrical side works, so we know what we are dealing with. This diagram varies in complexity depending on what exactly your van is equipped with. I will analyze a more dense diagram here, so I'm able to mention some of the extras. The core parts can be found in all of them though. At the moment this probably looks like spaghetti, so let's try to make sense of it. In the lower left you have the symbol for the battery. And right above that battery, both in the schematic as in reality, we have some fuses through which a number of permanent 12-volt lines are connected. On the negative side, the battery is connected to the body with the ground strap cable. All the grounds in the wiring diagram start with the letter M from the French masse, and they are all connected to each other through the body framework. With this information we can already add some color to the wires. Red for positive, black for negative. The dashed lines indicate switched lines, so these are potentially disconnected by some switching mechanism, like the ignition key, a manual switch or a relay. I realize adding the red probably makes it look even more like spaghetti, so let's go over some of the key components to hopefully make things clearer. Near the center we have the cabin fan. Great, the thing we are trying to control here. It is just a DC motor with a positive and a negative connection. In the bottom right we see our familiar fan speed selector switch. Behind the front there is a 5-pin switch, and when turning the switch different pins make contact. The ignition barrel is shown in the top left. When turning the key it closes the switch, allowing 12V to pass through. If you spend a few entertaining hours stripping away the dashboard, you get to see the barrel in all its glory. If you ever went hunting for a blown fuse, you probably also know the next two items: the dashboard fuse box and the engine bay fuse box. The rest I will handle tracing the connections to the fan motor. Starting at the battery positive fuse F70, we first pass the engine bay fuse F3, then back inside to the ignition barrel. This 12V switch signal then goes to another fuse F31 in the dashboard fuse panel, then back to the engine bay fuse box, where it energizes the relay R5. When active, this R5 allows another 12V to pass through that is protected by a fuse F8. And this 12V then finally arrives at the positive terminal of the fan motor. So, if we measure between the positive fan motor terminal and the battery negative, as soon as we turn the key in the ignition, that should be 12V. If it does not, we know either one of the fuses has blown, the relay R5 does not work anymore, the barrel switch failed, maybe a cable broke, or if Murphy is your pal, some combination of the above. Now let's follow the negative terminal of the fan motor. It splits off in 3 branches. The leftmost branch goes to an airco related module. At first sight it looks like this module can connect the negative terminal directly to the ground and thus let the fan blow at full speed. But on closer inspection I don't think that is what this connection is intended for. If I zoom in a bit closer, the components we have here are the switchboard, the engine management unit and the Freon pressure sensor. The switchboard is a small board sitting behind the temperature control panel. I don't think the connector at the bottom of it and the wires are rated to carry the full airco motor power. So this connection is probably meant as a sense wire to detect that the fan is on. Nevertheless, I will add it to the flowchart to check in case of unexpected fan behavior. I will zoom in on the 2 rightmost branches too, which are related to the fan speed selector mechanism. The way this works is that for most of the selections, the negative path is routed through a number of resistors in series. In reality, these resistors look like this. If you put more resistance in the path to a device, like a motor, less current can flow, so there is less power going towards the device. Each resistor you add in the series will add to the total resistance. In this case, that means the motor will turn slower and slower. Another way to look at this is that you have a voltage drop over the resistance. And the higher the resistance, the bigger the voltage drop over it, and the less remains for the motor. So let's look at the speed selector and how it uses the series resistors. On pin 1 we normally have a connection to ground. When the switch is in the lowest position, then nothing is connected to that ground and no current can flow. The motor is off. Now let's switch to the first position. The ground is now connected via 3 resistors in series, so its biggest value to the negative terminal of the motor. So from our 12V battery voltage, a big green chunk is lost in the resistors and the remaining grey part is available for the motor to spin at its lowest speed. Now if we switch to the next position, we see that we only go through 2 resistors in series, so the voltage drop becomes less. More voltage is available to the motor to spin faster. And more of the same for position 3, in which only 1 resistor is remaining. And finally in position 4 we completely bypass all the resistors and the motor gets the full battery voltage. It will spin at full power. So if your problem is that the fan works in position 4 but not in the other positions, you know something's up with the resistor element. Since the resistors heat up when they are restraining the current, they are placed in the airstream generated by the fan to prevent them from overheating. But over time the connections tend to corrode away. They are also protected by a thermal fuse as a safety protection against overheating. And this fuse can also be blown. In that case, it is best to buy a new resistor set, or alternatively, try to bridge the corroded connections or replace the fuse. This will probably already cover the system for most fans, but this diagram shows an extra optional system that can be installed, being an additional heating burner. This is a device that can burn diesel from the fuel tank to generate extra heat. It has access to the clock, the fuel level, the outside temperature, and can decide to start heating the van even if no key is in the ignition. To spread the generated heat around, it will activate the fan with these 2 relays, one for the positive 12 volt, one for the ground. The ground will go to 2 resistors, so the fan speed will match that of position 3. So, if your van is acting like it is possessed and starts spinning the fan even if you're nowhere near it, you probably have such additional heating and you need to take a look at its settings. And this brings us to the first check of the electrical side of the flowchart. Besides the additional heating controller acting up, the problem could also be that the relays controlled by it are stuck. Since I don't have such a system myself, unfortunately I cannot help with locating these components. The next scenario is one where, as soon as the ignition key is active, the fan is always running at full power no matter the selector switch position. I think the odds of this scenario happening are very small, but I will discuss it for the sake of completeness. There might be a short in the airco switch I talked about before, or there might be something wrong with the selector switch. For both, you need access to the heater control panel. It takes about 10 to 15 minutes to get to in real life, and I've added a sped up video in the last sections on how to do it. But I will skip to the end of that process here. The selector switch is screwed in on the back of the control panel. If you turn the back upwards, which involves a bit fighting against the pull of the cables going to the valves, then you can unscrew it, pull it out to test it and replace it if necessary. The airco switch module is easier to access. It is screwed in at the back of the white plastic frame. That white part can be detached after undoing the 2 screws holding it in place. Maybe you also need to unclip the 2 light bulb holders in the upper corners, but probably the retainer clips already broke off anyway, as the plastic gets brittle over time because of the bulb heat. I am busy making another video on how to replace these by LEDs. Subscribe if you want to be notified when it's finished. After removing the white frame, you have access to the module to test, fix or replace it. Make sure to also check for shorts on the cable that plugs into the airco switch module. On to the next and much more common issue. If your fan is working on the highest setting but not on some or all of the others, there is a tiny chance it might be a selector switch problem again. But you are almost certain it is the resistor element. The switch I just discussed in the previous issue. So let's show how to access the resistor element. Start by fully opening the glove box so you have access to all the screws. Be careful when you release the plastic stops. As is the case with all plastic stuff, they are very prone to breaking off, as you can see. Next, undo all the screws holding this panel in place. They are all Torx 25 screws. Then remove the panel, and at this point we can already see the resistor element. First remove the 5.5mm hex screw holding it in place. Then detach the connector like this. For getting the resistor out, notice that there are these clips that need to be pressed on both ends. It takes some trial and error in the beginning, but if you correctly press them, you can just slide out the resistor. As you can see, mine is still in an okay state. I removed a little bit of rust, put some heat resistant paint on it and reinstalled it. The remaining cases deal with situations where the motor just never works. To diagnose what's going on, unplug the motor connector and hook it up to a multimeter. Inserting spade plugs to keep your hands free for this helps, especially if you need one of those hands for filming, but you can also just measure on the connector with the multimeter probes. With the selector switch in the off position, turn on the ignition. Under those conditions, it should read close to zero or float. In my case, it does not float and it's close to zero, I assume because there is a high impedance path to ground via the compressor module. On all the other positions, you should read the battery voltage, since as there is no current flowing now, there will not be a voltage drop over the resistors. If the battery voltage is present, like I have here, then it is clear that it's the fan motor itself that is the problem. In that case, remove the motor by removing the screw holding it in place, rotating it and pulling it out. Note that you also need to remove the panel below to have enough room to do that. Take off the cover and inspect the motor. Possible causes for a non-working motor are that one of the connecting wires between the connector and the motor broke, or that the coil windings got damaged, for instance from overheating, or, like in my case where everything looks fine, it is the carbon brushes that have worn out. A continuity test with a multimeter confirms that the second one does not provide a good contact anymore. You can of course buy an entire new blower fan, but I like to repair things when possible and will show how to replace the brushes here. Getting them out is straightforward. You will need to cut through the crimped terminal to get them off, but make sure to use a strong enough cutter. The dimensions of the brushes are 6.5 by 9.5 mm, and they are about 20 mm long. The wire connects at the bottom. It turns out it is pretty hard to find these exact brushes. I found some that are slightly bigger, but then the wire exits at the back or at the side instead of at the bottom, so they don't fit. I also found one which was only 9 mm high and a bit wider, but with the correct wire exit. In the end, that one turned out to be quite usable after a little bit of reshaping. The missing half of a millimeter does not seem to be that big of an issue. I will put a link to these in the description. Note that the brushes have a beveled ending, which helps to better fixate the brush when the spring pushes against this bevel. So it is best to put that bevel on the new brushes as well. Route the brushes wire to the correct position. And then comes the hardest part in my experience, which is reattaching the brush wire to what I think are choke coils, mostly because there is not a lot of room to get to it with crimp pliers. I cheated a bit by first using a tiny bit of solder to attach the braided wire to the coil wire. And then used normal pliers first to already prefixate the crimp terminals to the bonded wires so everything stays more or less in place while I do the final crimp. Since I could not immediately find some terminals specifically for bonding parallel wires like this, I just used spade terminals and cut off the spade part when finished. Note that it took me at least half an hour of experimenting with different strategies and failing to finally get this far. After that, reinsert the bonded wires in its holder. And after checking that nothing is sticking out, reinsert the spring. I replaced the brushes on both sides and then it was time for a bench supply test, which luckily was successful. Note that the motor takes about 15 amps at full power. To reassemble the cover of the motor, I used some metal rods to make sure the screw holes lined up correctly, as you cannot see what you are doing. And then it's just a matter of putting the motor back in. In case you do not have 12 volt over the motor pins, the next step is to figure out if it's the ground or the positive side that has the problem. Remove the battery cover and test with the multimeter if we have 12 volt between battery plus and the black motor cable, which should be the ground. If we do, then it should be the positive side that has the problem, meaning there should not be 12 volt between the green motor cable and the ground. Double check to make sure. As seen in the schematics, there is quite a bit of fuses and a relay involved in the positive side. Most likely the problem will be with relay R5 or fuse F8, which are located in the engine bay fuse box. Remove its cover, which is held in place with two 8mm hex screws. F8 is the green 30 amp fuse. Pull it out and check it with the continuity test. R5 is the second relay here. Since it is quite hard to pull it out with all the surrounding stuff, I will show what it looks like using the bottom relay. There are two pins used to energize the relay's magnetic coil and then two pins that are shorted when the relay is energized. The function of the pins is visible with the diagram on the side of the relay. You can test the relay by putting 12 volt on the activation pins and checking that the two other pins are shorted. A quick first test is also to listen if you can hear it click when it's activated. If both the relay and the fuse are good, you can insert a spade plug in the relay sockets to check if the problem is that it's not getting the 12 volt and ground needed to activate it, or that there is no 12 volt on the pin that is being shorted. This way you know where to look further to figure out which fuse or maybe which wire is broken. Note that R5's orientation is 180 degrees flipped compared to the one I pulled out here for some reason. Also take into account that the location of the fuses and the relays tend to switch around in different models and years. So check on a fuse diagram and wiring diagram of your specific car before you start hunting. If it is the ground side that has a problem when the selector switch is in the highest position, the suspects are that switch, a broken cable, or relay 8091 if your van is equipped with one. And that concludes the fault finding flowchart. I already discussed the switch before, but as promised, I still need to show how to get to it. To get the radio out, you can buy a special tool, but it is just as easy with 4 metal rods or even some small screwdrivers. You just need to push inward some spring hooks so you can pull it out. Just pay attention to not insert them deeper than where the spring part is located. The focal splitters are a custom modification on my van. Probably you will have a bit less work here. And that concludes the second part. I hope it helped you fix your cabin heating problem. And if you ran into an issue I did not mention, put it in the comments.